Yep. Okay, so we're just going to do a few minutes of notes here, and then we're going to go into showing you the different reactions that you'll be working with. There's going to be 5 rates, 5 things that influence rate. You need to know what they are. I'm going to go through them pretty fast, so stay with me. The first one is the nature of reactants. If I put a rock in water, is it going to react with the water? Depends on what the rock's made out of. Okay, if the rock's made of potassium, yeah. If the rock's made out of calcium carbonate, yeah. Okay, but if the rock is just a rock like we usually find in a stream bed that water goes over all the time anyway, probably not. So the nature of the reactant is the first thing. Don't worry about this other stuff, just get the main idea. Yes? Yeah, very, very, very slowly. So it's the nature of the reactant, though. If it's something that is not going to react with this person no matter what, you know, if I put 2 kids in a room and they ain't going to get along no matter how hard I try to make them get along, okay, the reaction isn't going to happen. Okay, so nature of the reactants is the first one. We're not going to go into very deep on this, so we're just going to keep going here maybe. Okay, no, yes, surface area. So if I take and I make Kool-Aid with sugar cubes, is the reaction going to take place faster than if I make it with powdered sugar? No, it'll be slower, right? Okay, so particle size has to do with it. Same thing like if I'm at a lumber yard and I'm sawing stuff, they have to worry about what at the lumber yard, if it's enclosed especially? Dust. Because if there's a lot of dust particles around, it can cause an explosion with just a little spark. Okay, so same thing in flour mills, they have to keep the dust under control. Okay, so surface area. Come on. Missed one. I told you my board does not like me today. Let me come over here and I'll just say it from over here. So temperature is the next one. If I made something with hot water instead of cold water, the hot water will make it go faster normally, okay? Because they're moving faster and they'll collide faster. So temperature is one of the factors. Concentration. The concentration here at Northridge is about, what, 1,800 students. So trying to find somebody that you like probably is higher concentration because you have a higher concentration of choices than if you went to Lima, Montana, a graduating class of 5. Right? Okay. Catalyst. This is like the matchmaker in a wedding. They get those things together so that they react. So if I give a list of things that I would like in a future husband to a matchmaker, they go out, they find that person, they bring him back. I didn't have to do the work. Okay? All right, so those are the 5. And we'll talk about those things next time. Okay, so what I'm going to do is I'm going to shut this down. I'm going to show you those 3 labs. Okay, the first one, and we're hoping the chemicals get here in time, uses some chemicals. It is in a petri dish, and we're worried about how fast the gas is produced. Okay, so what we're going to do is we're going to take some universal indicator, and we're going to put, whoa, hello. We're going to put a drop or 2 in there, and we're going to put a drop or 2 on the lid. And the one on the lid is just so that we know what it looked like originally. So we know when there's a change. Okay, now inside, we're going to put some sulfuric acid. It's not real strong, but it's strong. I'm going to put a couple of drops, and I'm going to do it opposite where the indicator is. Okay, and you need to decide how many drops and what you want to do there. And we're going to put a couple drops of sodium sulfite. Now it'll produce a gas, so I'm going to put this over the top, and we just wait and we time the reaction to see how many seconds it took for that to change color. Now you got to decide between you and your partner, are we going to wait till the whole thing changes? Are we going to wait just till the outside edge changes? How are we going to measure that? Yes?
In the actual experiment, do we put the other liquid on top of the original one, or is it on the opposite side like you just did?
You want it opposite of this is an indicator on this side, and this was where I mixed the 2 chemicals to make the reaction. So I mixed over here the sulfuric acid and the sodium sulfite.
How is that going to react with
This one right here is just an indicator. It lets me know when the gas is produced.
Oh.
It'll change pH. Okay, so we'll sit here and watch it for a few seconds. Hopefully it will work because this is the only sodium sulfite we have left. And so if the sodium sulfite doesn't come from Flynn in enough time, we won't be doing this part of the reaction. We'll tweak one of the other two. So you're going to be testing it for concentration, temperature, or particle size. Which one could you use this one for? Could you use particle size on this one? No. Concentration would be a good one. I also have a little plate that I'm going to put at each area that's plastic that you can put underneath and fill it full of warm water or cold water or ice. Okay, so I could change the temperature. Okay, so this one I could change the temperature. Can you see how it's starting to change color? It's a little slow. It's because my stuff is cold. Okay, so the warmer probably was going to be faster. So next to this experiment, which is one of the ones that you got to do, you want to put down which ones you could use this one for, which we decided was what? Concentration and temperature. So I can use this Petri dish for concentration and temperature. Okay, and you can see it's starting to go orange. If I move this a little bit, you can see it a little bit more. Okay, it'll take and go bright orange if we just leave it. So I'm just going to set this aside because we're getting low on time, and I'll bring it back and show you in just a minute. Okay, the next one that we do, and I'm going to put another white piece of paper under here or two so you can see it, is in a well plate. So we're going to grab a well plate. Okay, and on that well plate, we're going to get some magnesium ribbon, and you'll get one strip, and you can cut it up however you want. Okay, and you're going to put, and I'm not going to be real exact about this because I'm just showing you the reaction. You and your partner need to decide how you're going to do this. You're going to put some hydrochloric acid in a well. Okay, and then you're going to put in the magnesium ribbon. Okay, now temperature, concentration, particle size. What can I mess with?
Particle size.
Particle size, what else?
Concentration.
Concentration, because I could add some distilled water to that because I'll have distilled water. You
You
could do temperature because I could take this and I could put this in the plate. It's giving off hydrogen gas. Okay, so there's a couple that I could use this one for all three. Now particle size, I can only cut this in so many little particles. So maybe the next one will be better for that. Okay, I'm going to put this other one back under so you can sort of see what's going on here. Now I would time that one, last one until, see how it's changed? I just need to be a little bit more patient. I don't have time. Okay, so you need to decide, is it the first hint of orange that we want to time it, or do we want it all to be orange? Okay, the last one, so I'll let that one fizzle here for a minute. Plop, plop, fizz, fizz. Oh, what a relief it is. Yep. We're going to take this one, and this one we're going to actually do outside. We're going to do it outside by the doors out here. You're going to get a film canister. And the film canister, and this is important to write this down because you won't have this before. It won't be on there. The film canister has these marks. 3/4, 2/3, 1/2, 1/3, 1/4. So you can vary the amount of water, okay? You could vary the temperature of the water, and you could also vary the particle size. You'll be given one thing of antacid pain relief, effervescent, okay? That gives you 2 tablets that look like that, okay? You need to, on each of these, do minimum of 3 trials. Okay, so on this one, just because I want to just show you how it works, is I'm going to take some water, a little bit of water, and I'm going to go out in the outside by the thing. So I filled it with water, and I've got my thing here, and I'm just going to take and I'm going to put that in, close it, and turn it upside down. And I'm going to wait. Oh, bummer. That one was a boring one. We're going to have to do that one again. Okay, sorry. No. So we're going to do it again. I might have picked one that didn't have a really good sill. Here, I'll put it over here so you don't have to have it by you. Okay, so you turn it on its lid and you're going to go, that's better. You're going to go the height and you're going to go the time. Now, notice I only used a half of a tablet. You actually can use less than a half of a tablet. A fourth of a tablet does fine. But you're going to do size of particles. If you do size of particles, you got a mortar and pestle. You can grind it down. Okay? But you're going to do height on the bricks and time. So write your little note on what one you can use, because when you come next time, that's what you're going to do for quiz time. So write your lab up. Okay? All right, if you please make sure the chairs are up and all that fun stuff. Oh, here. This one is totally after. Now this one's totally changed back. Can you see that? So it almost goes a red. So you need to make a decision.